detected. This output wasn't an over-enhancement of noise. It was a clear pattern emerging from the data, a pattern that matched theoretical predictions for what Planet 9 should look like. With a mass estimated to be between 5 and 10 times that of Earth, and an orbit that takes tens of thousands of years, this object could finally be the missing piece that explains the unusual orbits observed in the far reaches of our solar system. If this kind of mind-blowing science excites you, make sure to subscribe. We dive into discoveries like this every week. Before we dig deeper, let's revisit the history of Planet 9. First proposed in 2016 by astronomers at Caltech, the Planet 9 hypothesis emerged as a solution to a puzzle. Why do many trans-Neptunian objects have orbits that are clustered in one direction? The idea was that an unseen planet, a massive, distant body, was exerting its gravitational influence, shepherding these objects into similar paths. For years, astronomers searched for direct evidence of this elusive world, but the vast distances and dim light made it nearly impossible to capture with conventional methods. The James Webb telescope, with its cutting-edge infrared capabilities, promised to change that. But only if we could extract meaning from its enormous datasets. And that's exactly what the quantum AI system has done. This isn't your typical telescope image. The quantum AI isn't merely enhancing images. It's using probability fields to predict where the faint light from a distant object should appear, and then cross-referencing that with gravitational data. This method provides not just a single snapshot, but a dynamic model that evolves over time. A statistical reconstruction of an object that has long remained hidden in the darkness. As we explore this breakthrough, keep in mind that what we're seeing is the culmination of years of theoretical predictions meeting state-of-the-art technology. It's the product of an ingenious marriage between quantum computing and astronomical observation, a marriage that is reshaping our understanding of the cosmos. Now, what exactly could this mysterious object be? Scientists are currently split between two main theories. Theory A: the object is a conventional planet, a gas giant or an ice giant, somewhere between 5 to 10 times the mass of Earth. Its slow, elliptical orbit takes it far from the Sun, which is why it has remained undetected for so long. This theory aligns with the original predictions of Planet 9, a massive body whose gravity would shape the orbits of countless smaller objects in the Kuiper belt. Theory B: a more radical idea proposes that the object might not be a planet at all, but a primordial black hole, a remnant from the early universe. Though minuscule in size compared to a star, such an object could still possess enormous mass, exerting a gravitational influence comparable to that of a large planet. This theory, though speculative, is supported by the unusual infrared signature detected by the quantum AI system, something that might indicate an object that does not emit light in a typical manner. Both theories are groundbreaking in their own right. If it's a gas or ice giant, we're talking about the discovery of a new planetary body that forces us to rewrite the textbooks on our solar system's formation. If it's a primordial black hole, then we're not just revising planetary science. We're confronting the possibility of exotic objects that bridge astrophysics and cosmology. Regardless of which theory is correct, the fact remains. The data points to the presence of a massive, dark object in a region where nothing like this was expected. And that's a game changer. As if the discovery itself wasn't startling enough, there's an unexpected twist that has the scientific community buzzing. When the quantum AI system analyzed the object's movement, it noted that the gravitational influence of this body does not perfectly align with existing models. Instead, the object appears to wobble. Its motion shows irregularities that could hint at additional factors at play. One possibility is that the object has a small orbiting companion, a moon or even a ring system, adding complexity to its gravitational signature. Alternatively, the wobble might indicate that the object is surrounded by a field of debris, or that it's interacting with other unseen bodies in the outer solar system. Even more intriguing is a subtle, rhythmic pulsing. In its heat signature, the AI detected a narrow band reflection that appears to pulse at regular intervals. While some scientists caution that this might be due to natural processes, others are left wondering, could this be a sign of artificial interference? While highly speculative, the idea that this object might be more than a mere planet, or even that it could be a remnant of an ancient engineered system, has ignited imaginations around the world. This twist forces us to consider that the outer solar system might harbor complexities far beyond our current understanding. Every wobble, every pulse of heat, every minuscule deviation in its expected orbit serves as a clue that points towards something truly extraordinary. If you've made it this far, you're clearly into the deep stuff. Hit like and let us know your theory in the comments. Is it a hidden planet, a primordial black hole, or something even stranger? Let's pause and reflect. We're standing on the brink of a discovery that could reshape our view of the solar system. Imagine for a moment that every gravitational nudge, every stray photon, every minute anomaly captured by the James Webb telescope is a message, a cosmic breadcrumb leading us to a new world. This is the kind of moment that scientists dream about. It's not a definitive answer, but it's a tantalizing glimpse into a puzzle that has perplexed astronomers for years. The quantum AI system has given us a roadmap, a statistical reconstruction that hints at the existence of a massive, unseen object that has quietly been influencing the motions of countless distant objects. What does this mean for our place in the universe? For the first time, we might be able to add a new chapter to the story of our solar system, a chapter that introduces a mysterious, dark presence at its very edge. Whether it's a conventional planet or something far more exotic, the implications are profound. They extend from our understanding of planetary formation to the very nature of cosmic evolution. Digging deeper, let's consider another layer of speculation. Some theorists suggest that this object might not be isolated at all. It could be part of a larger unseen system. One hypothesis posits that Planet 9 could be a captured rogue planet, an interloper that was once part of another solar system and was gravitationally snared by our sun. This idea isn't entirely new, but the precision of the quantum AI's findings gives it fresh credibility. Alternatively, there's speculation that the object might be the remnant of a dwarf star system, perhaps a small star, long dead and collapsed into a dense core, wandered too close to the outer solar system and was captured by the sun's gravity. This could explain some of the irregularities in its movement and the unusual infrared signature. If true, it would challenge our definitions of what constitutes a planet versus a stellar remnant. Across the scientific community, debates are heating up. Researchers are comparing the newly discovered anomaly with similar signals in other star systems, looking for patterns that might indicate a broader cosmic phenomenon. Is Planet 9 an isolated oddity, or does it hint at a common process in the evolution of solar systems?